Hello friend, how are you? So today we are solving this daily lead code problem 3201. Find the maximum length of valid subsequence 1. So we are given an integer array nums. A subsequence sub of nums with the length x is called valid if it satisfies like this. That if we are taking two consecutive values and it's percent 2, so whatever is the whether this sum is even or odd, the next set including the previous, right, like sub 1 is coming in the common in the next set of the sum. Okay, so in this way the basically it should be same if we do the modulus with the 2. This is the condition. So we have to find the length of the longest valid subsequence that satisfies this condition. So we can understand better way. For example, this is our nums. Now we have to find that which satisfies this condition, right? So we will check that what could be the possibility. So you guys can observe here that this is nothing but if sub 0 and sub 1, whether this is an odd or even. This is what we are checking. So if we are picking any sequence, either it should make sum of the any two consecutive terms equal to either even or odd. That is what we have to check. So let's look for this example. So suppose in this case we can have multiple things. Let's say we are picking only even numbers, so 2 and 4 and 8 and 4 and 6. We can pick these guys, right? And this will make our condition satisfied. 2 plus 4, that is an even. Then 4 plus 8, that is also an even. Then 8 plus 4, even, right? Or we can also pick only the odd numbers. So in case of even, how many numbers were there? There were 2, 4, 8, 4, 6. So there are size total 5. So 5 length we can easily get here. But we don't know. We have to find the longest one. So okay, so let's check for the only odd numbers. So we can start from 1 to 5, 5 to 7, 3, then 7, then 3, then 1, right? So we found here how many? 2 and 2, 4, and 2, 6 and 7. So we found with the even numbers 7. So that's better than previous one. So for odd, for evens we found 4, and for odds we found 7. Now we have another possibility, that what if we find the alternatives, right? So that would be the sum would be making here the odd. So what does it mean is, first let's say we are starting with an even number, then next should be the odd number, right? So 2 plus 1, this will generate the odd number, right? 2, 1. Then what is the alternate would be, next should be an even number. So 2, 1, 1, 4. Now 4, 7, then 7, 8, right? Now we need next one odd, so 8, 3. Now when need next one as even, 3, 4. Then need next one odd, 4, 1. Then 1 to 6. So in this way we found 9. So now you can observe there are 3 possibilities to get the that we have to check basically. We just cannot go that only the even or odd would be there. We have to check these 3 possibilities. So what those 3 possibilities? Either we are picking the even count, that is even sequence, or we are picking for the odd count, right? Or we are picking the alternative count. These 3 possibilities we have to check. So here, as we have checked here, with the even number we found the count equal to 4. For the odd number we found the count equal to 7. And for alternative positions we found the total count equal to 9. So we have to do in this way. So we can do all these things in single pass itself. We don't have to do multiple passes for this. Only single pass would be enough. So let's say we have 3 values, these even, odd, and so initially even would be 0, odd also would be 0, and alternative I am taking 1 because I am starting, let's say, for whatever number, the next if it is different 1, then only I would be having directly a count equal to 2. So I am passing alternate count equal to 1. Okay, So now we will start here. So we will take one variable here called previous. Okay, this previous would be basically picking the value of the previous term. Okay, so previous we are taking here the one which is sitting at very first location. So this would be 2, right? So now what will happen when we are starting from this position, I equal to 1 we are starting. Okay, so what is the very first guy? Very first guy is even, right? So before starting, this even count should become 1 because very first itself an even, right? Now we are from I equal to 1 we have to start. This is I equal to 1 index, right? So from here we have to start. So hey, what it is this at I equal to 1, this is odd, right? So we will increase odd by 1. So our odd would become now 1, right? Because 1 is an odd number. Now we will check this previous, that hey, is this guy is opposite of what is the previous guy. So previous guy is an even number and this guy is odd number. So what we will do, alternate we would be increased by 1. So alternate would become now 2. Okay, so now we are coming here. So what this is an odd number, so odd count would become now 2. We are increasing the odd by 1. Now we will check that our previous in the step previous we became previous would be updated by 1, right? Because this I equal to 1 we have already done. So we will check this. So what is the previous here? So this current is 5 and previous is also current is odd number and previous also odd number. So alternate would be same. Alternate will not be changed. Now we are coming here. So the count of odd would be increased. This would become now 3. Yes. And does it equal to opposite of previous? No. Previous is also odd and this guy is also odd. Now we are coming here. This is also odd. So now our odd count would become 4. And is it opposite of previous? No. Previous is also this only, odd only. Now we are coming to 4. So this is an even number. So our even count would become 2. And is it opposite of previous? Yes, this time it is opposite of previous. And previous is currently the previous value was 1, right? So if it is opposite, then we will increase the count of alternative by 1. So it would become now 3 and our new previous would become 4, right? So our new previous now becoming 4. Now we are at here 7. So this is odd number. We will increase the count by 1 of odd and we'll check, is it opposite of previous? Yes, it is opposite of previous because previous is an even number. So alternate now would become 4, right? Now we are coming here. So we have to update our previous. So our previous would become now 7. Currently it is taking the value 7. So let me make it 7. Now we are coming here at 8. So 8 is an even number, right? So we have to increase the count of 8 first. Then we'll check the previous, that is it opposite of previous? Yes, previous is 7. This guy is even. So this count would be increased by 1 and our new previous would become 8. Now we are coming at here 3. That we'll check, hey, is it so odd would become now 6, right? So let me make this itself. So odd became now 6 and is it opposite of previous? Yes, previous is an even number. So our this also alternate would also increase. So in this way, when we will keep on going, okay, so finally we would have alternate having the value equal to 9, right? And this guy odd would be having value equal to 7 and even would be having at the end value equal to 4. So we have to return whoever is maximum. So for even count it is 4. For 2, 4, 8, 4, 6. 2, 4, 8, 4, 6. So even count would be total 5 here that we have to update. So this guy finally would be becoming 5 and the odd count would be 7. So here we have to check what is the maximum. Even is 5, odd is 7 and this guy alternative is coming as 9. So whoever is the maximum, that should be our answer. So in this case 9 would be our answer. So this is what we have to do. And that we can do in single pass. So this is my code. Let me show you my corresponding code here, which is pretty straightforward. These are the values. These variable even count, odd count and alternate equal to 1. And previous we are starting with the very first value. So we are checking that previous is odd or even. So if it is even, we are increasing even by 1. Otherwise we are increasing odd by 1. Now see here, we are using this for loop starting from I equal to 1. So here I am checking whether it is opposite, whether if it is opposite means alternate way is coming or not, right? So we are checking just like we were checking here for this previous stuff, right? So that we are checking here. So if it is opposite of what was the previous, so their modulus with 2 would be different. So that is why we are increasing alternate plus plus, and previous is updating with the current value. Okay, now at here we are checking that if this existing current number in the nums, is it even or odd. If it is even, we are increasing by 1, otherwise we are increasing by 1 for odd. So finally when we are coming out of it, we are returning the maximum of alternatives count and even count and odd count. So whoever is maximum, that we are returning, and we are not taking any extra space, and only single pass we are doing. So let me execute this code, so which I have already submitted. So let me submit it. We are taking O of n time complexity, and we are taking no extra space. So thank you for watching this video, and if you guys have any concern, please make a comment over there. Thank you.